Okay, so let's extend the fun we've been having with two-dimensional vectors into three-dimensional vectors. And I want to start by teaching you how to draw vectors in 3 dimensions. There's a bit of a process to this, and what I would recommend is that you go and get yourself a nice basic transparent ruler like this. Here is the system for drawing 3-dimensional vector spaces, drawing 3-dimensional graphs. We want to start like this. First thing we do is we're going to draw a vertical line like you're used to seeing, but this is not going to be the y-axis. This is in fact going to be the z-axis. That's step 1. Step 2 is going to be drawing a line like this. We're going to draw a straight line across. There's a couple ways to do this. This is the way that most physics books will do it, and I find this is the easiest way to keep track of where your points are in space. So we're going to draw another line, and you may be tempted to think this is the x-axis. It is not. We are actually going to call this the y-axis. The last thing we're going to do is draw a line outwards like this. And this is going to be the x-axis. I know it looks kind of weird like this, and so let me go ahead and draw a square in this 3-dimensional space to give you some perspective on what the numbers are doing here. So the way we draw a square here is, let's go ahead and use the notches on the ruler as our marks on the graph, and we're going to ignore the grid lines, because grid lines work great in 2 dimensions, but in 3 dimensions, these do not line up. So what we will do is mark out, let's go 1 centimeter on the x-axis, 1 centimeter on the y-axis, and 1 centimeter on the z-axis. Now the way we then do this is we draw a line parallel to the y-axis, a line parallel to the x-axis, like this. See how it's slanted? And a line, if we wanted to go up, we could draw some lines here, parallel to the z-axis, or excuse me, to the x and y axes. It looks like it's just to the y-axis here, but in 3 dimensions we're actually going to draw a plane, and so the square might look something like this. 1, 1, and another, not quite 1. And that's just due to the perspective. So I told you I was going to draw a square. I actually lied. This turned into a bit of a cube here. But this is a cube in our 3-dimensional space. Notice how it doesn't look quite cubular, if you will. Part of that is due to the perspective shift needed to make this work. So the way we have to project 3D space onto 2 dimensions is we tend to lose some of the clarity that you get on a 2-dimensional graph. That's why we try to simplify things to the 2-dimensional case when possible, because this is cool to look at, but to analyze information about it, you have to be much more kind of precise with your thinking when you go to find something like this point right here. You have to go, okay, x is going to be 1 centimeter, y, we have to go another centimeter this way because these lines are now parallel. So even though if we went straight up, this would be 0.5 centimeter, going parallel to the y-axis here, we have our point that's 1 centimeter. And it looks like in this specific spot, z is 0. Up here, z would be 1. Up here, z would still be 1, even though it's higher. But that's purely because we need to visualize this as a cube inside our paper. And that can take some time to get used to seeing. The nice thing, though, is you can always shift your perspectives around. You can draw these axes in different spots and try and get a visual on what's actually happening here. You'll get hang of it, though. You'll get the hang of it. So just take your time, practice with these. Use as many numbers as possible to denote things like, okay, 1, 1, 0 for this point. Over here, we have 0 on the x-axis, 1 on the y-axis, 1 in the z-axis. And you just do this with every single vertex of the cube. And eventually you might start to picture things, what's going on, and just take time. It's going to take you probably a good week and a half of working with these to get used to thinking in 3 dimensions. But you'll get there. You might already be there too. So a lot of wide range of people that consume physics content. Hopefully this does make sense. What we are going to do now is give you an example of a similar problem that we did to the one in the previous video, which is in our Physics Foundations playlist if you are looking at that. And we are going to do an example in 3-dimensional space. So let's go ahead and do that now. And I'm going to give you a 3-dimensional vector, which means we are going to erase our little cube here. And I did make the mistake of writing in pen, so unfortunately those are going to be stuck with us. But that's okay. Let's turn them into vectors. So I'm going to draw a vector from the origin out, and this vector is going to be the vector 0, 1, 1. Notice how I changed the brackets to the angle brackets to denote that this is now a vector. Now be careful. It does look like it's just on the YZ plane, and in this case it is. But in some cases, you might have a vector, like let's say one that goes here, that would look to be on the YZ plane. But because of the perspective of it, if I have my two planes here, I can have a vector that might look to be very short, but is in reality, say this silver pen, quite long, and you're just looking at it from the wrong perspective. So make sure to pay attention to the numbers that represent the vector and not the shape that they make on the graph. It can be helpful sometimes to see this. Most of the time, it's going to confuse you until you're very good at spotting kind of the perspective of these vectors. And so when I can, I try and denote the perspective by drawing my arrows parallel to the axes that this vector is on. So this vector is, you can see it has 0 in the z direction. So I try and make this look very flat as possible and have a big arrow to kind of show it pointing out into the screen at you. See how that pen tip's really big, and then it gets a lot smaller if it's going the other way. So I'm trying to do that with the arrows here. Hopefully that helps. But we are going to call this vector A, and we are going to call this vector B. We've done this before, so we're going to do it again. And let's write these in two forms. Let's write them in the standard basis vector form for A, and then just to get practice, let's do B in that linear algebra notation that I've shown you before. So A is going to equal 0 times the I hat vector. We don't do anything in the x direction. So 0 I hat, and usually you can just not write that. You don't have to. Plus 1 in the y direction, which is what we call 1, what is that? J hat, plus 1 in the z direction, 1 k hat, and that's our new basis vector that we will learn to play with. And again, we can write this as 0, 1, 1. We'll do the same for B. B is equal to, in this case, 1 I hat plus 1 J hat, and I'm not going to write the K hat term because it's a 0 there, so there are no multiples of the K hat. We don't do anything to move any units up in the Z direction. So that's done. But when we write it in our vector form, since we are dealing with 3 dimensions, we need to have the 0 there. Otherwise, we might think this is a 2-dimensional vector xy, and it's not. It is a 3-dimensional vector, and we need to make sure that people know this is x, y, and z, not x and y. See how the x now gets confused if we do this? So make sure that when we write in the vector form here, that we do have all 3 dimensions, since this is a 3-dimensional vector space. So again, we will do 1 I hat, 1 j hat, 0 k hat, or 0 in the z direction. These are our 2 vectors. Now if we want to then do A plus B, it's going to, again, be the same process here. So I'm going to make one big one, and we're going to do 1 plus 0, 1 plus 1, and I'm just adding them up according to their basis here. So according to each axis, I should say, 0 plus 1, which is going to equal 1, 2, 1. This is the new vector, and we can go ahead and draw this out. So let's remember, we're using the centimeter now as our standard basis because these grid lines aren't super helpful. So we are going to go 1 centimeter out here. And what I like to do is then actually draw a parallel line so you know that's 1 centimeter out. 2 centimeters in the y direction. So starting where the x is, we're going to go 1, 2 centimeters in the y direction, and 1 centimeter in the z direction, which is going to bring us right there. Now, pay attention, because now we have a vector that, if I were to represent this in a 3-dimensional space, might look something like that. It might point out to about right there on our graph in 3D. However, because we are compressing that information onto a 2-dimensional piece of paper, that vector kind of looks like it's just super close to the y-axis. It's not. It's actually a whole 2 units into the y-axis and a unit away from it on either side. However, the two-dimensional information can confuse you. So make sure that we do have this, and again, we'll call this C. Great. And again, if we wanted to do A minus B, just flip all of these to minus signs here, and then that would give us, we'll call that C2 is equal to 1 minus 0 is 1, 1 minus 1 is 0, and 0 minus 1 is negative 1. And we can, of course, write that in the standard basis vector notation as I hat plus 0 j hat minus 1 k hat, or I hat minus k hat. And this is also a fair way to describe this vector. So all of these are descriptions for vectors, and they are ways to talk about them. It is a language like any other part of mathematics, which means it takes time to practice and learn. If it's still a little unfamiliar right now, that's okay. You're dealing with three-dimensional math, maybe for the first time in like all of your science and math career. So take some time to get used to this. There will be some practice problems that I'll try and find and link below. I think that's most for this video though. So take a look at this, learn, practice with the three-dimensionality of it. And in the next video, we will actually start our deep dive into physics. Maybe I'll have a little vector field video next, but hey, as usual, if this is helpful, go to our Physics Foundations playlist. There's a lot more cool videos to teach yourself physics, and do like and subscribe if you found this at all interesting. I'll see you guys in the next one. Thanks so much for watching. Peace.